Okay, folks, it's time to try something that's just a little bit more challenging. As you can see here, we're going to look at simplifying these expressions, ones that are slightly more difficult. Okay, now I would say that, how many of these problems would you see on the test? Only one, maybe two. Okay, I'm going to try to stay away from real difficult problems. I'm just going to rely on the really essential ones. The test is all the way at the back there. So here's what I do. I look at the tangent squared of theta over secant minus 1. And right away, your attention might be drawn to secant minus 1. And I would understand, right all the way at the back there. There should be one that says test. There you go. You can grab that and just take that right out there. Okay, so here's what we're going to do. Is I look at this sheet, I can see that secant squared minus 1 is tangent squared. But I don't see something that says secant of x minus 1 is tangent of x. That is not true. We can't just substitute that in at all. But I can do something else. And I'm going to show you the substitution that I'm going to make. Instead of punching in tangent squared for, say, secant squared minus 1, I could go the other direction, and we'll see if it will make sense to you as I do. I look at this piece right here, and instead of substituting something in for the bottom, I'm going to substitute something in for the top. We all agree that tangent squared is secant squared minus 1, right? Now, right now, you're like, what the heck is he doing? Well, watch. If I have x squared minus 25, does that factor? What does it factor to? That's the difference of two squares. Does secant squared minus 1 factor? That's the difference of two squares as well. Secant of theta minus 1 times secant of theta plus 1. All over secant of theta minus 1. What cancels? And so you're left with secant of theta plus 1. Kind of tricky. I see what you're doing. So what you want to do is you want to take, say, 8 minus 1 over 4 minus 1. And what you're like is 8 divided by 4 is 2, and negative 1 divided by negative 1 is positive 1. So that equals 3, right? When really this is 7 over 3. That's what you want to do. That's what you're saying. No, look at what you're doing. You're going to take, so if I have 8 minus 1 over 4 minus 1, what you're saying is you're going to take secant divided by secant to get secant, right? So 8 divided by 4 is 2. And then you're going to take negative 1 divided by negative 1. Negative 1 divided by negative 1 is positive 1. So you're saying that that's 3. That's the voodoo math you're going to do right there. That's what you're trying to do. Now, you're right. As you look at this, it does work out that secant squared divided by secant is secant, and negative 1 divided by negative 1 is positive 1, but you will not get that credit on the test. And that will not work out all the time. You're trying to do voodoo math. This does not equal 3, folks. This equals 7/3. You can't just cross stuff out like that with your fractions. Excellent point. I'll show you. If you have, say, 8 minus 6 over, say, 10 minus 8, you could factor a 2 out of the top to get 4 minus 3. You could factor a 2 out of the bottom to get 5 minus 4, right? The 2's will cancel, and you'll get 1 over 1, which is 1. In this case, yeah, 2 over 2 is 1. That works when you factor something out of the top and out of the bottom. But you weren't factoring something out. You're just saying, I'm going to cancel parts, which is totally illegal. That's like saying 4 plus 1 over 1 plus 3. Hey, I'm just going to get rid of the 1s. It's 4/3. That's a new branch of mathematics that you can invent, but it will not work. Okay. Let's try again. Okay. So, sine squared. Okay. I see a cosine of theta plus 1. It's not a cosine squared. So I'm kind of out of luck. But it's a sine squared on the bottom. So what could I substitute in for sine squared? Very good. 1 minus cosine squared of theta. Sine squared is the same as 1 minus cosine squared. Can I factor 1 minus cosine squared? What does it factor to? Thank you, Tito. Are these two the same? They are. So I can cancel those two out. And I'm left with 1 over 1 minus cosine of theta. Part of what you need to learn in this process is that it's nice to get things that are squared. When they're squared, I can substitute pieces in. So this squared piece, there's something I could plug in. Let's look at letter C. Is there anything squared in that example? There's nothing that's squared. I'm going to make something squared. How do I make something squared in this example? What would I do? Distribute. What's secant times secant? Secant squared. And what is the relationship between secant and cosine? They are reciprocals. And when you multiply two reciprocals, you get 1. Do we know what secant squared minus 1 is? What is it? Tangent squared. The birthday boy is sure talkative today. Would you like to teach the lesson? It's your birthday. Why don't you teach the lesson? Okay, nobody will buy the book, but it's all right. We'll talk about it. The day math was invented in a new way that doesn't work. So it'll be wonderful. And we'll celebrate, and we'll bring treats again. But all right, okay. So again, in this situation, I have a squared here, but I'm going to develop another squared. I'm going to distribute the sign through. Sine times sine. And then as I multiply sine, cosecant, and cosine squared together, what is the relationship between sine and cosecant? They're reciprocal, so I just get 1. So there's a 1 in front of the cosine squared. Huh. Does that look familiar? Does it, Tito? Which number on your sheet does it look like? Number 5 says what? Sweet. I could tell you what sine is. Remember when we did the unit circle? We had x, y. And when we had a coordinate, we had this was y, this was x, and this was r. Sine was, thank you, y divided by r. The way that your calculator knows what sine is very, very complex. It involves a lot of calculus. Oh, excellent. Thank you for asking, Andy. Everybody take out your calculator. Okay, I'm going to go into mode, and I'm going to go down to degrees, okay? And now we're going to put Andy's question to the test. He says, if I just put sine squared and add cosine squared, do I get 1? Give me a 3-digit number. What, 314? All right, so I'm going to take the sine of 314. Notice how I have to enter it. I'm taking the sine, and then I'm squaring it. That's what it means to do sine squared. Plus, parentheses, cosine of 314 squared. So we're going to square the first value and square the second value, and we get, give me another 3-digit value, Miss Haley. Oh, okay, give me 2. Give me 1. What do you want? Give me 4. Give me 8. What do you want? 26? 26, delete. 26, delete, and enter. Boom. If your calculator wants a value, would you like me to prove to you right now that sine squared plus cosine squared is 1 regardless of any angle? You want to see it? Okay. We'll do it. Watch. In terms of x and y and r, do you remember what sine is? Sine is y over r, right? Agreed? So you're going to square that. You okay with that? Plus, what is cosine? Right? And we get something over here, and you want that something to be 1, correct? So we get something. Okay? So we get y squared over r squared plus x squared over r squared. Is that something? You okay with that? Do you remember this? What? When you're working in the unit circle, do you remember what the radius always is? It's always 1. Right? Do you remember? Do you remember the equation for a circle? X squared plus y squared is equal to r squared. Very good. So I want you to think about this, okay? Now, you have x squared plus y squared is r squared, right? You told me that r is always. So if it's 1, then we just end up with y squared, right? And if r is 1, we just end up with x squared, right? And you told me that x squared plus y squared is the same thing as r squared for a circle. And what is your radius? just proved that sine squared plus cosine squared is 1. Let's try another problem. Okay, flip it over. Okay, let's try this. What do I do now? Now I've got a binomial times a binomial. Uh-oh, this looks challenging. What do I do? 1 times 1? 1. 1 times cosine? Negative cosine times 1. Negative cosine. And negative cosine times cosine. Negative cosine squared. I multiply all out. What happens there? What happens to the middles? These middles cancel out. And I get 1 minus. What is 1 minus cosine squared? You guys are doing your own proofs. You are doing proofs. You're doing... We just did. We just proved something. You guys... I argue that you guys actually like proofs. You are actually doing it right now. You don't even know it, okay? You try the next one on your own, okay? You try the next one on your own. Let's try it. I'm going to have tangent squared plus tangent times secant minus tangent times secant minus secant squared. What happens to the middles? They go away. And you're left with tangent squared minus secant squared. Do you see that written on your sheet? Look at your sheet. Do you see that written anywhere? Where? I see secant squared minus tangent squared, but I don't see tangent squared minus secant squared. I could, yeah, watch, I could get it. Look, I'm going to take this one right here. Sometimes you got to make up your own rule. I'm going to subtract the secant squared over. I have 1 plus tangent squared minus secant squared is equal to 0. No, it's not. I just subtracted it over. Now I don't want 1 plus tangent squared minus secant squared. I want just tangent squared minus secant squared. So what should I do? Minus 1. And I get tangent squared of x minus secant squared of x is equal to negative 1. No, so here, no. What I'll show you for those of you who don't really like that, I'll do it this way: tangent squared of theta minus. What can I put in for secant squared? What does your sheet say? Instead of secant squared, I could write. No, I could write. It's number 6. I could write 1 plus tangent squared. So let's say you want to do it like that instead. You didn't like my other way, okay? I distribute the negative, and I get tangent squared minus 1 minus tangent squared. What happens? Tangent squares go away. You're left with negative 1. So there's multiple ways of doing it. Multiple ways of doing it. Okay. Let's skip a couple here. Let's go to K and L. Do you recognize K? K is like a problem that we did just the other day. Factor what? Very good. Cosine squared, I'm going to factor it out. When you factor out cosine squared, what are you left with? 1 plus cotangent squared. Do I have something that I can plug in for 1 plus cotangent squared? Do you see that? I can plug in cosecant squared. So I have cosine squared times cosecant squared. What do I write instead of cosecant squared? One over sine squared. And I get cosine squared over sine squared. What is cosine squared over sine squared? Cotangent squared. We'll do one more together. Letter L. I'm going to distribute the cosecant. What is the relationship between cosecant and sine? What do I get when I multiply reciprocals? So you get 1 minus 1 times cosine squared. Cosecant times sine is, so if you have 2 times 1 plus 3x, you take 2 times 1 to get 2, and you take the 2 times the 3 to get 6x. You don't take 2 times 3 and 2 times x, do you? Because they're paired together through multiplication. So same thing here. Cosecant times sine is 1, so the 1 attaches to the cosine squared. And what's 1 minus cosine squared? Which number is that on your sheet? It's sine squared. We didn't get through them all, but how about this? Tomorrow, we'll do our review game. No assignment. We're going to practice these together, okay? We're going to get you up in front of class. We're going to practice them. There's going to be no assignment. There is an assignment tonight, but there's no assignment tomorrow. So don't get your hopes up too much. But tonight will be short. I have 5 problems, or 6 problems, and I'm going to show you a couple other pieces tomorrow. They're actually quite nice. So if there's a couple problems you can't do on here, don't worry. I'll help you through it tomorrow as well. Okay, so we'll practice tomorrow. Happy birthday, birthday boy.